Students, welcome to the sixth lesson of matrices and determinants. In today's lesson, we'll be learning about symmetric and skew-symmetric matrices. To learn the concept, let's see a demonstration. As I've told you earlier that today we'll be watching that the given matrices are symmetric or skew-symmetric. Let's consider the first one, in which they are saying whether A plus A transpose is symmetric or not. For verifying that whether A plus A transpose is symmetric or not, we need to simplify A plus A transpose first. Let me write A matrix, and then to find A transpose, I will write A matrix with a transpose on it. The first matrix will remain same as it don't need any change. But the second matrix has transpose, so I'm going to write rows to the columns. After changing rows to the columns, there is addition sign between them. So I will add corresponding entries. 1 plus 1, 2. Then is 2 plus 0 is 2, and 0 plus 2 is 2, and 1 plus 1, 2. I've added corresponding entries over here. It's the answer of A plus A transpose. In order to verify whether it is symmetric or not, we'll take its transpose again. We have learned in the previous lecture that if we want to see that whether the matrices are symmetric or not, we'll take their whole transpose. As you can clearly see, when I will take its whole transpose, I need to change rows to the columns, and if I will change rows to the column, I will get back the same thing which was already with us. Let's take transpose. A plus A transpose whole transpose will be, again changing rows to the column will give me the same thing. Now observe this thing, that when I took the transpose, let me take the transpose, changing rows to the column, this row will become the column, and second row will become the second column, and it didn't affect it at any cost. It remained the same. You compare A plus A transpose whole transpose with A plus A transpose, there wasn't any change, so we will say that A plus A transpose is symmetric as it has satisfied the symmetry condition. Consider the next question in fact, in which we will be watching that out whether A minus A transpose is skew symmetric or not. Keep in mind the condition of skew symmetric. What is the condition? The condition is that if A transpose is equal to minus A. So let me simplify the question first, which is not in simplified form. I'm going to write A minus A transpose, and what was A? A was 1, 2, 0, 1. Let's write that. 1, 2, 0 and 1. Then minus sign, and now I have to take transpose of A. Transpose. So for the next step, I'll be quoting A as it is. Then minus, I need to take its transpose. Again, I have to shift rows to the columns. So now again, as it contains minus sign, we'll subtract the corresponding entries. 2 with 0, it becomes 2. 0 with minus 2, obviously greater value sign will come, and 1 minus 1 will be 0. Now the next thing is, for watching this skew symmetric, again we need to take whole transpose. So let's take that. By taking whole transpose again, this was our question. A minus A transpose is our question. Taking whole transpose again, changing rows to the column. What has it become? I'm going to take its transpose, and for taking transpose, 0, 2 is row, now it has become column. Minus 2, 0 was the second row, now it has become second column. Now check that out. The entries are exactly same, but only the difference is of minus sign. So if I take minus sign as common, what I will get? I will get the same matrix A minus A transpose, but with negative sign outside, which was the condition of skew symmetry. So A plus A transpose whole transpose was A minus A transpose whole transpose was equal to A minus A transpose, which was a condition of skew symmetry, hence verified that A minus A transpose is skew symmetric. Let's apply these concepts on today's question. Here I've quoted the question from book again, and I've given you two matrices A and B. The matrices are at your front. What you will be doing, you will be proving, in fact, there, because the question is of verification. It means it's true that they are whatever it's written with the question, whether it's symmetric or skew symmetric, you have to prove it. But for that, first you'll be simplifying the question, and then you'll be taking whole transpose. And if after taking transpose, it will be again the same question, you'll be saying that it's symmetric. But if you need to take minus sign as common, you will say that it's skew symmetric. I hope you have learned in a good way, and you will be finding ease after application of this question. Thank you.